Good morning, everyone. Welcome to geometry class. Today, I would like to talk about construct congruent triangles. In general, two geometric figures are congruent if one of them could be placed on top of the other. And fit exactly. Point for point, side for side, and angle for angle. However, if two triangles are not on top of each other, how do we decide if they are congruent triangles or not? Yes, I will have solutions for you. Now, first, let's understand the definition of congruent triangles. So let me move the page. The definition of congruent triangles: all pairs of corresponding parts. What corresponding parts means? All pairs of corresponding parts are congruent. When triangles are congruent, their corresponding parts, sides, and the angles are equal. We are talking about the length, the order of letters in the congruent statement indicate which part correspond. So let me show you. Side AB, do you see I have one mark here? And the same one mark here, DE. Side AB equals to side DE. And when we talk about two marks here, BC equals to EF, and we have three marks here. AC should equals to DF. How do we know that? Because they tell you two triangles are congruent, and the letters has its own orders here. AB, DE, AB, DE. And let me change color. BC, EF, BC, EF. So same thing, AC equals to DF. And then when we talk about the angle, angle A equals to angle D. Why? Because angle A is here, angle D is here on the first place. So angle A equals to angle D. And then you can use the same numbers of the mark, like three marks here. So you can visualize which part equals to which part. So that's one part. That's another part. Okay. So each part equals to which one? All decided by the order when you write down congruent triangles. So the order of the letters, very, very important. So that's the first thing you want to pay attention. Okay, keep going. After we understand the definition, you understand that you don't need to always put the one triangle on top of the other triangle to tell they are congruent or not. Now, when we are talking about the corresponding parts of congruent triangle, need to be congruent. I will say corresponding parts of congruent triangles are congruent. Do you know why mathematicians always try to create some formulas? Because mathematicians, they are kind of lazy or they don't want to waste the time, so they want to have shortcut. So C, P, C, T, C are the shortcut for all those very long words. So CPCTC, CPCTC. So next time, if you are doing the proof and you would like to say corresponding parts of congruent triangles are congruent, you don't need to write down the whole statement. You just write down C, P, C, T, C. Then everyone, whoever learn geometry, they understand you. Okay, so that's a shortcut you can use. Next, I would like to talk about the logic of definition. So when we say the definition of congruent triangles, basically we say if two triangles congruent, triangle 1 congruent to triangle 2, then CPCTC. Agree? All pairs of congruent corresponding parts are congruent. So corresponding parts of congruent triangle are congruent. Now, when we talk about the logic, if then, let me use the first statement, I call it P, and the second statement, I call it Q. If then, we can say if P, then Q. Obvious, right? And we have a symbol. If then, we say P, then Q. We use this symbol. Means if P, then Q. There's the same thing, equivalent, same thing. Now, when we talk about definition, actually, it's more than just the if then. When it's definition, let me add one more arrow here. Need to be two ways. If P then Q, and also if Q then P. So definition is something like you and your name are totally equal. See, this name is you. See, you is this name. Okay. Probably my instruction is not perfect. My example, because probably more than one person have the same name with you. So forget about the example I just showed you. But for definition, if two triangles are congruent, then CPCTC. If two triangles CPCTC, then these two triangles are congruent. That's how we said this is the definition of congruent triangles. Okay, so you can read through P if only if Q. When you have two ways, means it's reversible, and we call this if only if. Some books say if and only if. So there's a symbol for if, only if. And the if only if means two parts. One direction and the other direction. Okay, if P then Q, or if Q then P. So that's the logic of definition, if and only if. Let me move the page, go down. So let me have the final version of the statement. P, if only if Q, and in other words, you can separate to 1 and 2. P, then Q, or Q, then P. So that's the definition of CPCTC congruent triangles. And the next thing is the question of how do you prove triangles are congruent? It's not an easy job because we have 6 pairs of the parts need to prove. Fortunately, so let me show you. You don't need to prove all 6 parts to guarantee 2 triangles are congruent. So we have some postulate. Postulate, remember I talked about postulate on my first video. Postulate is something like a theorem, but the theorem you have to prove it. Postulate is no way to prove it because it's too obvious, and it's kind of like a common sense. Everyone agree, and no way to prove it, and you just treat it like a common sense. You accept the postulate. The problem is, you may say the teacher, I don't feel those postulates are so obvious to me. I don't feel like they are common sense to me. Yes, I agree. Some postulate, like the postulate right now I'm going to talk about, is not that obvious to you right now. Okay? But that's my job to make sure you feel those postulates, they are all obvious to you and they become common sense to you once you watch my today's video. Okay? Now, before I talk about that, let me show you. We have several type of the triangles here. Excuse me. Okay. So let me quickly go through the name of different type of the triangles. You probably already understand, already learned. Equilateral triangle means one triangle has all 3 sides are equal. So I mark the same mark, 1 mark here. Okay, usually I have 2 mark, 3 mark, means all 3 sides are different. But since I have all the same mark, means all the sides are equal. Let me change the color. All 3 sides are equal. So we call it equilateral triangle. If only 2 sides equal, the other sides not equal, then we call this isosceles triangle. And how about if all three sides are different? Then we call this scaling. No sides are equal. And the acute triangle, all angles are acute. Acute angle means less than 90 degrees. Right angle means equals to 90 degrees, but only one, okay? Only one angle is 90 degrees. Then the other two angles should be acute. Because three angles plus together only equals to 180. And 180 is 90 plus 2 acute angle. Okay? And obtuse angle, if you have one angle greater than 90 degrees. So those different type of the triangles you would like to prove they have congruent triangle by using those postulates. Now in the video, I will just choose a very special triangle to show you how to understand the postulate. And how about the other 5 type of the triangles? Yes, I will use this one to show you the postulate for HL, because HL actually is HL with angle 90 degrees. It's a right triangle. So I will choose only 2 triangles to show you the concept of the postulate. And for the other type of the triangles, if you have enough time, I hope so, you may try to construct congruent triangle for each type of the triangles. Okay, now keep going. Let me explain the way I can convince you to accept those postulates are common sense to you and are obvious to you. I will use the construction, how to construct. Okay, construct congruent triangles. Go through construct congruent triangles. You may feel those postulates are obvious to you. The first thing is you may construct a congruent triangle on top of the original triangle to see they exactly fit point by point, side for side. You can do that. Okay? So today I will try not to make this congruent triangle on top of the original triangle. Why? Because when I show you the graph on top of the other graph, it's not easy for you to see the difference. Okay? So I will construct a congruent triangle on the side of the original triangle. And that's your job. You can try after you learn how to construct a congruent triangle on the separate place. You may try to construct your own congruent triangle just on top of the original triangle to see if they really fit exactly on top of each other or not. Okay? Now, so basically today the most important thing, there are 2 things. First thing is I will show you how to construct congruent triangle. And number 2, you want to verify those 4 portraits really is obvious, common sense or not. So there are 2 things, but the most important thing is how to construct congruent triangles. Okay, so let me keep going to next page. So let me read through my own writing. We may understand above postulate through constructing congruent triangles. Now, there are 2 important tools to construct congruent triangles. Number 1, construct congruent 9 segment. Number 2, construct congruent angles. Keep in mind, one triangle has 2 things: angles and the side. The side basically is 9 segment. So as long as you know how to construct a side, congruent side, they are equal lengths. And as long as you know how to construct congruent angles, then you are done. You just repeat the same thing, and then you can easily construct congruent triangles. Okay, now how to construct congruent triangles? Basically, it's more than just 1 and 2. So that's why you have to pay attention for the rest of the video today. Okay, so first, keep going. We try to learn how to construct congruent 9 segment. So first, I need to give you a 9 segment. Here I call it AB, and I try to use compass to construct CD on the 9L. Means if you want to construct something on top of the original AB, you can do that after the class. But right now, I would like to show you how to construct a separate congruent 9 segment on 9L. Okay. And actually, it's very, very easy. I show you the steps, 3 steps here. Okay. So first step, you choose a random point C on 9L. So on the 9L, we choose a random point C. You decide C. Okay. And then you want to open your compass to be exactly the same size of length AB. Okay. So say the length of AB is R. So you open your compass to the length of R. Then put this tip on C, and then use the pencil to draw an arc. This arc may intersect with 9L at one point. We call it D. Then we have already construct 9 segment CD. So repeat. Step 1, choose a random point C. Step 2, use C as a center. And AB as a radius R. So this is AB. Okay. Now you mark an arc and intersect with 9L with point D. Then we are done. So please practice at your own piece of paper, and then we can keep going to the next one. So we have 2 tools. First tool, draw a congruent 9 segment. Second one, you want to construct a congruent angles. Given angle A here, and you want to construct angle D on ray N here, and that's the point D vertex. And guaranteed you want to measure angle A congruent to angle D, the measure of angle A congruent to the measure of angle D. So how to do it? Same thing, I provided you 3 steps. Okay, we only need 3 steps. Okay. Use point A as a center and choose a random radius R. So say, let me see. So I randomly choose a radius R here and open. Use this one as a center and open my compass. And radius R, I can draw an arc. So I call this arc to intersect ray L with point B. So this is point B. And this arc intersect with ray M at point C. Ray M at point C. Okay, this is ray M at point C. So you have ABC here, and then you want to use the same radius R to make an arc on the center D. So this R, and how about the other R, right? Where? So that's my next step. Okay. Next step is you try to measure, try to draw a 9 segment or measure Okay, let me see. Okay, here. So let me review. First step, we open a radius R and draw an arc, this arc. And then you have a point B and C. Okay, you have point B and C. That's the first step. So that's a step 1. And the step 2, use this point D and use the same radius. So you draw another arc. And this arc, we call the arc K. We call the arc K, and intersect ray N at the point E. So we call this point E. So right now you have D and E. But where is F? Okay. Now, next, step 3. Let me change a color. How about red? Okay. So, use E as a center. So, step 3, use E as a center. And you try to draw an arc, right? But what's the radius for this arc? You use BC as a radius. So we call it radius 2. How about that? So BC, where's BC here? This radius 2. You use BC as a radius. And then you mark an arc here. You use E as a center. And you use radius R2. Let me draw a better straight line. Okay. Draw. Okay, pretend this is a straight line. Okay, R2. And this, when you use R2 as a radius and the E as a center, you draw another arc. This arc intersect with the previous arc K at one point. I call this name F. Okay, I call it F. So this is step 3. You find the F. Okay. One more time. Step 3. Step 3, you use E as center. Use E as center. And then use R2, which is BC. You use BC R2 as the radius. And draw an arc here. This arc. Let me use special color. Draw an arc. So use E and the R2. So you have arc. So this is step 3. Okay. Then you find the F. Okay. So with these 3 steps, then you have DEF. Okay. So you connect DF to have red DF. So here I connect DF. Let me use black color. I connect DF. My draw is kind of ugly, huh? Okay. Connect DF, and then keep going. So this will be DF ray. So you have DF and DE, this ray, and this ray, DF and this D. Okay. Now after you repeat to practice with these 3 steps and the last 4 step, you learn how to draw a congruent angles. And then by using these 2 tools, we want to talk about actually when you want to draw a congruent triangle, you only need to have 3 pairs of the parts congruent. Now, which 3 pairs of the congruent parts you need? First one, SSS, means 3 pair of the sides congruent. Then that's good enough. Even we don't talk about any angles. 3 sides congruent will guarantee 2 triangles congruent. So here I will show you how to construct a congruent triangle by using 3 congruent sides. And you may, after the class, you try to construct a congruent triangle by following those 5 steps on top of the original. On top of the original triangle. You can do that. And to see if they really point fit point and side fit side. Okay. So right now let me follow the step 1 through step 5 on the separate place. So first, let me draw a construct DE. Step 1, construct DE congruent to AC. So that's AC, I construct DE. How to construct? I'm not going to show you how to construct again, okay? So say this is my ugly line. Let me try again. Okay. Okay, pretend it's straight line, okay? Pretend longer. Pretend it's a straight line here. And let's follow my construction. It's DE. Okay. So that's step 1. I construct a congruent 9 segment. Construct okay. How to construct a congruent 9 segment? I just talk about that, so I don't show you exactly the way. And then step 2, use D as a center and the AB as a radius. So radius here, radius 1. Draw an arc L. So use D. Okay, let me change the color. So to measure 2 arcs has 2 different color. So use AB as a radius and the D as a center, and the draw. So let me draw better. Use your compass to draw an arc. So I call this arc L. Okay. And remember, this is R1, right? This is R1. You don't need to mark this one. Okay. And the step 3, use E as a center and the BC as a radius. Okay, let me change color again. Which color? Green. Okay. So use E as the center and then this BC as a radius R2, and then draw another arc. Okay, so I say this, and then we call it arc M. Okay, let me make sure this is L, and this arc M different. Now arc L and M intersect at one point. This one, F. Now, when you connect DF, what happens? Let me show you. If you connect DF, this is a radius 1. So guarantee AB equals to DF. Yes? And then when you connect EF, okay, when you connect EF, let me draw better. Connect EF. Better. So this equals to R2 because there's a same radius of the green arc. And then we guarantee to have AB equals to DF, and the BC equals to EF, and the AC equals to DE. Okay, now the next thing is, how do I know? By doing this, these two triangles will be congruent. The answer is here. How many triangles can be constructed with base DE? So on the base DE, do you believe there's the only one triangle I'm able to construct? Yes, you only find one point F, right? So there's the only one congruent triangle. No matter you draw this triangle somewhere else or on top of the original triangle, they should be the same triangle because the only one. Exactly only one triangle can be constructed. Next, when given AB, AC, and the angle A. AB, AC, and the angle A. So you have S, A, S. This A means angle. Side. So side, angle, side. We call this SAS postulate. When given SAS, then you should be able to construct only one, not the only one, you can construct congruent triangle. Now, let's try. Let me keep going and try to construct, show you how to construct. Okay, so follow my 4 steps. First, construct DE congruent to AC. So that's a blue color here. Okay, AC. Now I say this is DE, DE congruent to AC, and then construct a ray L so that angle A congruent to angle D. So there's a green color. You want to construct a ray. Basically, you want to construct angle D. And this angle D start on DE and end here. We call this ray L. Okay. And then step 3. So this is step 2. And this is step 1. And then step 3, we use this color. Step 3, we want to construct DF equals to AB. So DF equals to AB about here. DF. Okay, so that's step 3. So on the ray L, we construct DF equals to AB. Now, what do you have to do? The rest is you connect EF. Then you are done. Again, how do I guarantee there's only one triangle can draw on the DF to be congruent to triangle ACB? Other than if you do it here, upside down, you may do it upside down here. Maybe you can say, okay, teacher, I can do 2, but actually they are just a reflection. Okay, so these 2 are the same thing. We can prove it later, but not today. Today we focus on introduce those postulates. And here, so we don't want to talk too much to confuse our students here. Okay, so basically, let me see. What happened to here? Never mind. Okay. So I think that's okay. Let me cover this. Let me cover this. That's the something I covered before. Okay. So in the end, you only have two connect. Connect EF. Then you are done. Okay. Now, how many triangles you can construct? Only one. Because when you construct a DE, there's only one DE you can construct. And when you construct DF, there's also only one DF here. So there's only one possible. Now keep going. We talk about, so I will say only one. Change color. So only one means when you try to draw on top, you try to follow the same steps and draw a triangle on top of the original triangle. This is the original one. This the triangle you can construct. Follow step 1, 2, 3. Should give you point for point exactly fit, and the side for side exactly fit. You can try by your own. Keep going. We goes to ASA. So ASA, if I give you angle A, angle C, and one side in between these two angles, so we call this ASA. A means angle. Angle, side, angle. We call this ASA postulate. If I provide the angle, side angle to you, then you should be able to construct the congruent triangle. So same thing, let's follow the instruction. Let me erase so I can have space. Okay. 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 So same thing. First, we have to draw DE equals to AC. DE, let me see. DE. Okay, say this. DE equals to AC. So that's step 1. Step 1. And then step 2. We want to construct angle A equals to angle D. So we construct a ray L. So this angle D equals to angle A. So this is step 2. And then we want to construct angle C equals to angle E. So from angle E, we construct angle C equals to angle E, and this we call it ray M. Ray M. So this is step 3. Okay, so you can see that where is F? Where is vertex F? No other choice, right? So the only one choice is F should be here. So when you connect, then you have the only one congruent triangle here. Okay, so then we are done. This is step 4 and step 5. Can you connect? Then how many triangles can be constructed with base DE? Yes, only one. Okay. So same thing, you can try this 5 steps on top of the original triangle to make sure you agree with they will have exactly fit, point for point, side for side, angle for angle. Now, HL, when you have hypotenuse and the leg, we are talking about the 90-degree right triangle. Need to be 90 degree. So given hypotenuse H and one leg opposite or adjacent or called legs. Okay. Now here I choose the example when you have this leg. CAB, no, sorry. In my example, I choose this leg, AB and BC. Okay, this leg, AB. So it looks like S, 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 A. When it's SSA, only when angle A is 90 degree, then we have the postulate to guarantee congruent triangle. If this angle is not a 90 degree, won't. So same thing, you can go home to try to see if not a 90 degree right triangle, what happened. So let me follow my steps, show you. Okay. Oh, okay, here. Okay. It's better here. Okay, first, excuse me. So step 1, let me change color. Step 1, construct DE equals to AB. DE DE equals to AB Okay. And then second step is very easy. We can just use a ruler. Use a ruler to construct angle D equals to 90 degrees. As long as 90 degrees, then should be equals to angle A, right? So this 90 degrees, 90 degrees. So this angle start from here and end this angle and at ray error. So we need to construct a ray error. Basically, that's the same idea. We construct congruent triangle, which we had done earlier. So after you can use a ruler. You can use a ruler to construct. Now, after you construct ray error, so that's the second step. I say use ruler to construct. And the pink color is step 1. Step 1. Oh, let me change color. Step 1, step 2, and then step 3. Use E as the center and the BC as radius. Where is BC? BC is the hypotenuse. Okay, so hypotenuse we call it R1. So we use R1 to draw an arc. Draw an arc. Let me see. Draw an arc this way. And you probably thinking about I pre-draw the picture here, so that's why it's the only one. I draw the picture here. I put the photo here because it's easier for me to draw a straight line. Oh, let me see this. It should be this way. It's better this way. Okay. Okay. So this we call this one step 3, and this arc we give it the name arc M. So you use BC. BC. Let me show you BC. You use BC as radius to construct arc M. So this is step 3, and we construct arc M. Step 4, let me change color. Step 4, name the intersect of ray error and the arc M as vertex F. So this is vertex F. Step 5, connect DF and the EF. DF and the EF. Then we have our congruent triangle finished. How many triangles can be constructed with base DE? Since the vertex F is the only one intersect Therefore, you may find only one congruent triangle. Which satisfy 90° and the same hypotenuse and the same adjacent leg. Okay, so same thing. If you want, you can try to construct a congruent triangle on top of the original, on top of this original triangle, and you can see we'll have a point for point perfect match, and side for side perfect match. So this is the congruent triangle for 90° HL. Next, the last page, we already learned how to use the portrait, SSS portrait, SAS portrait, ASA portrait, and the HL portrait. And you may try all those portraits on each of different type of the triangles here. Okay, and the HL only apply when you have a 90° right triangle. Now next, we have some questions for you to end this video. Other than the previous SSS, SAS, ASA, and HL, other than those portraits, how about, do you think about SSA, AAS, or AAA? See, we have SSS. How about AAA? So number one question, SSA. How about SSA? SSA you may try if you have a 90° for sure, and the SS, or 90° for sure, you have SS. We all call this SSA. SSA. But also because of 90°, we know this is a hypotenuse. Therefore, this is HL and 90°. This also HL 90°. In this case, we can try it fit HL postulate. It works. However, if this angle not equals to 90°, say this angle is obtuse angle more than 90°, or this angle is acute angle less than 90°, and you have side 1, side 2, and the angle. Side 1, side 2, and the angle. You can try to construct a congruent triangle with S1, S2, and A. And you will see how many triangles you can construct. It's more than one triangles. Okay. Only when angle A is 90° can guarantee that. And I will leave this for you to try by yourself. Therefore, SSA not 90°, we don't have this portrait to support you to construct only one congruent triangle. Number 2. AAS. AAS, basically, if you had angle 1 and the angle 2, then angle 3 is already there. Angle 3 equals to 180 degrees minus angle 1 and minus angle 2. So, if you want to construct one congruent triangle with angle 1, angle 2, and one side, basically, by calculating, you already have angle 3. Since you already have angle 3, then you have ASA. See? ASA is one of the parameters that we can use to guarantee there's only one congruent triangle. So number 1, I said no. Okay? If not 90 degrees. And the number 2, I will say yes. AAS is equal to ASA equals to ASA. So yes. And the number 3 is something very interesting. You have only angles, only provide the angles. So you didn't tell me what type of size of the side. So angle 1, angle 2, angle 3, with the same angle, we can construct many different type of the triangle with same angle. 1, 2, 3, and you can try more. Now you probably already realize with the same angle, same corresponding angle, same corresponding with the same corresponding angles, different side, different size. Okay, the corresponding side not equal, but the corresponding angle are equal. Now, with the corresponding angle equals, they have same shape, but different size. It's so obvious. Therefore, we say no guarantee, not sure, have congruent triangles. If AAA and the SSS, then yes, right? But they didn't say SSS. Therefore, only AAA can only guarantee same shape triangle. Same shape triangle, in other chapter, we are going to talk about them. The official name is similar triangles. The triangles have same shape, so they look similar. And they look similar, maybe same size, maybe not the same size. If same size, then it's called is congruent triangles. If not the same size, we call it similar triangle. So today, in the end, other than congruent triangle, and later on, in the next chapter, we are going to learn similar triangles. Okay. Now, thanks for watching today's video, and I will see you next time. Bye bye.